Hello. We're going to talk about electrochemistry, a clear domain. I am Mickaela Pangilinan, and my colleagues are Calvin Ong, Lance Nangel, Jericho Milagros.
So, electrochemistry is present everywhere, especially in our environment and pollution. Pollution is created by human activity and is where harmful or poisonous substances are becoming present in our environment. In simpler words, it is the natural world as a whole or in a particular geographical area that is affected by human activity.
Now we're going to talk about possible results offered by electrochemistry. The framework for normal protection in industrial generally fuse techniques for waste treatment similarly as a progress of new strategy or things which have more or less frightful effect the earth. Electrochemistry methodology can be used for recovery or treatment of effluent from current or city plants. Current electrochemistry has encounter an improvement towards cleaner structure and earth all around arranged things. Its sensors and feasible and prudent device can command checking of a growing extent of harmless substances.
Hi, I'm Calvin Jhone Ong, and as we can see here, there are two processes which are anodic process and cathodic process. Anodic process is where the transformation of any contaminated substance into innocuous or safe substance by oxidizing. It is also to purify the harmful mixes present in pipe gases. As for cathodic process, it's the reduction of hydrogen ions that makes solution less acidic and more alkaline. It is also to purify the poisonous mixes present in pipe gases. The figure on the right is a presentation of how the anodic process and cathodic process takes place. With its one-of-a-kind capacity to oxidize or diminish mixes at a very much controlled terminal potential, and by simply including at the anode or pulling back at the cathode electrons, offers many fascinating prospects with regards to natural designing. Standard reduction potentials provide a systematic measurement for different molecules' tendency to be reduced. It is also a category known as standard cell potentials or standard electrode potentials. Standard cell potential is the potential difference between the cathode and anode. These are all measured at 298 Kelvin, 1 atmospheric pressure, and 1 mole solutions. However, in the figure presented, substances are measured in volts. Now, we will discuss the electrochemical procedures for waste treatment. There are a lot of electrochemical processes for waste treatment that have been developed over the years. It focuses on the clarification, disinfection, and reduction of the cost. This is very efficient and reduces process detention times, thereby allowing smaller plants or substance. First is the working conditions should be thoroughly and professionally controlled to avoid side responses. The side responses affect the productivity, which may result to expansion of working expenses and discompose the needed procedure. If the said condition are experienced, new electrodialytic forms are created that will be responsible for the natural issues. Not exclusively can the two anodes of the electrochemical cell be utilized in sanitation forms. Yet, the particle-specific films that are frequently positioned between the cathodes to have a particular exchange of just ions or cations can likewise.
Cyanide poisoning is one of the most famous poisons. From spy novels to murder mysteries, it's developed a reputation for causing an almost immediate death. Electroplating is the process of plating one metal onto another by hydrolysis, most commonly for decorative purposes or to prevent corrosion of a metal. There are also specific types of electroplating such as copper plating, silver plating, and chromium plating. Electroplating allows manufacturers to use inexpensive metals such as steel or zinc for the majority of the product and then apply different metals on the outside to account for appearance, protection, and other properties desired for the product. The surface can be a metal or even plastic. Cyanide solution. A sodium cyanide solution is commonly used to leach gold from ore. There are two types of leaching, heap leaching and vat leaching. Heap leaching is spraying a cyanide solution over huge heaps of crushed ore spread atop giant collection pads. The cyanide dissolves the gold from the ore into the solution as it trickles through the heap. The pad collects now metal impregnated solution which is stripped of gold and resprayed on the heap until the ore is depleted. Vat or tank leaching. The ore is mixed with cyanide solution in large tanks. Although the chances of spills are lower because of the leaching process is more controlled. The resulting waste, known as tailings, is stored behind large dams which can and do fail catastrophically. Electrochemical process. The anode is cyanide plus 2 hydroxide ion minus hydrogen plus 2 electrons. The cathode is metal deposition with hydrogen evolution as a side reaction. The temperature is negative 50 to 90 degrees Celsius. The current density is negative 500 ampere meter raised to negative 2. The chemical method is cyanide to cyanate using hypochlorite sodium as an oxidizing agent.
Hello, I'm Ezekiel Joshua M. Pante from Group 7 and I'm going to discuss about chlorine in drinking water, the chlorination and removal of heavy metal ion. First, chlorine in drinking water is the process of adding chlorine to drinking water to disinfect it or clear germs. Different processes can be used to achieve safe levels of chlorine in drinking water. Chlorine is available as compressed elemental gas, sodium hypochlorite solution, or solid calcium hypochlorite. While the chemicals can be harmful in high doses when they are added to water, they are all mixed and spread out, resulting in low levels that kill germs but are still safe to drink. Second, it's an effective disinfectant, and lastly, chlorine in drinking water terminates a large amount of microbes in water. The second topic is the chlorination. The chlorination is any reaction in which chlorine atoms are removed from a molecule. Example, burning, natural method utilizing extraordinary microorganisms or catalysts, and etc. Furthermore, film partition adsorption on initiated carbon and stripping compound oxidation with air, ozone, or different oxidant. And lastly, in dechlororination, compound decrease methods. The third topic I'm going to discuss is about removal of heavy metal ions. Removal of heavy metal ions are created in metallurgical and electroplating businesses and in the assembling of printed circuit sheets. Secondly, complex metal particles in soluble arrangement hydroxide precipitation is certainly not a reasonable technique. And lastly, the removal of heavy metal ions utilize hydroxide precipitation gives voluminous metal hydroxide that must be discarded. The removal of heavy metal ions is important in our everyday life since it's used for businesses and metallurgical or any building establishment that provides businesses that focuses on building buildings.
I'm Nangel, and for this slide we're going to tackle the removal of heavy metals. But first, what are heavy metal ions? The term heavy metal refers to any metallic chemical element that has a relatively high density and is toxic or poisonous at low concentrations. Example of these includes mercury, cadmium, arsenic, chromium, thallium, lead, etc. And every heavy metal presents different hazardous effects on us. Heavy metals are naturally components of the Earth's crust. Although they are naturally occurring elements, most environmental contamination and human exposure result from anthropogenic activities, such as mining and agricultural use. They cannot be degraded or destroyed, and the contamination of these metals are one of the most important environmental issues. Therefore, appropriate steps need to be taken to reduce heavy metals and metalloids in water to acceptable levels. Several methods have been used to remove heavy metals from contaminated water. They include chemical precipitation, adsorption, membrane filtration, reverse osmosis, and many more. In this slide, we can see a diagram of electrodialysis. Electrodialysis is a membrane process during which ions are transported through semi-permeable membrane under the influence of an electric potential. The membranes are cation or anion selective, which basically means that either positive ions or negative ions will flow through. Cation selective membranes are polyelectrolytes with negatively charged matter, which rejects negatively charged ions and allow positively charged ions to flow through. By placing multiple membranes in a row, which alternately allow positively and negatively charged ions to flow through, the ions can be removed from wastewater. Ingestion of the vaporous species in a fluid. There are products that contains a chemical called amine oxide. If these products are inhaled or swallowed, they can be highly toxic and can even be fatal. Electrochemical change. Oxidation of nitrous oxides to nitric acid. Nitric oxide and nitrogen dioxide formula is one of the several components of automobile exhaust that create smog. This process is normal and favorable. Nitric oxide passes into the exhaust with the other gases and then cools so rapidly that the nitric oxide can revert back into its original form. Then once released into the atmosphere, nitric oxide reacts to form nitrogen dioxide, which is familiar as the brown hazy color of smog, which can lead to acid rain. Sulfur dioxide to sulfuric acid. This has serious environmental consequences. Since the sulfuric dioxide can dissolve in the water vapor, clouds to form dilute sulfurous acid and sulfuric acid, this, along with nitric and nitrous acids which are produced in the same way from nitrogen oxides, forms the basis of acid rain. On the right side, as we can see, we have a diagram called fuel cell. For this to work, the hydrogen gas comes in contact with the platinum surface and the electrolyte where it is oxidized and loses electrons. Then, the hydrogen ions migrate to the cathode where they assist in the reduction of oxygen gas, and for the electrons, they form at the anode and pass around the external circuit, and it will become an electricity. Electrochemical power sources for cleaner electrical energy. The world's growing energy need, alongside increasing population, led to the continual use of fossil fuel-based energy sources like coal, oil, and gas, which became problematic by creating several challenges, such as depletion of fossil fuel reserves, greenhouse gas emissions, and other environmental concerns. These problems will create unsustainable situations which will eventually result in potentially irreversible threat to human societies. Since renewable energy supplies are obtained naturally from ongoing flows of energy in our surroundings, this means that renewables are increasingly displacing dirty fossil fuels in the power sector, offering the benefit of lower emissions of carbon and other types of pollution. But not all sources of the energy marketed as renewable are beneficial to the environment. For it to be sustainably renewable, it must be limitless and provide non-harmful delivery of environmental goods and services.
This is Group 7 signing off.